Okay, so let's get right into it. This is a story that kicks off in a quiet university lab and ends up with, well, with the power to either remake our entire world or unmake it completely. Today, we're unpacking the atomic age. Was it our greatest leap forward or our biggest and possibly final mistake?
To really get the sheer scale of what we're talking about, we have to start right here, at the moment of creation and destruction. After seeing that first mushroom cloud bloom in the desert, the project's lead scientist J. Robert Oppenheimer remembered this line, "Now I am become death, the destroyer of worlds." It is just an absolutely chilling quote that kind of hangs over everything that comes next.
And that's the real mystery here, isn't it? How on earth did a moment of pure scientific genius, a discovery about the very fabric of reality, lead humanity to the edge of wiping itself out? That's the question we're going to try and answer.
To get that answer, we've got to rewind. Way back. Back to a time before the bomb was even a nightmare, when the atom was just this fascinating and supposedly unsplittable puzzle.
So let's follow the breadcrumbs. It all really starts in 1917, when a guy named Ernest Rutherford actually splits an atom, proving it wasn't this tiny, solid thing after all. Then you get the 1920s with these incredible Solvay conferences. Think of it as the Olympics of physics. You've got Einstein, you've got Curie, all these brilliant minds literally rewriting the rules of the universe. And it all leads to this critical moment in 1938. Two scientists, Hahn and Strassmann, discover fission, but it's their colleague, Lise Meitner, who was literally fleeing the Nazis at the time, who realizes what it means, the terrifying possibility of a chain reaction.
So what actually is fission? Well, put simply, it's taking a really heavy, kind of wobbly atom, like uranium, and breaking it in two. When it splits, it becomes two lighter atoms, and in the process, it releases a huge amount of energy. And that energy, that's the key to everything.
And right here, this is where the story takes a dark turn. The wonder of pure discovery gets completely overshadowed by the threat of World War II. All of a sudden, this isn't just a cool theory anymore, it's a weapon just waiting to be built.
Now this letter, you can just feel the panic coming off the page. A physicist named Leo Szilard was terrified that Nazi Germany was getting its hands on uranium, so he convinced the most famous scientist on the planet, Albert Einstein, to put his name on a letter to President Roosevelt. The warning was stark. Germany could build an atomic bomb, and they could get there first. That letter is what officially kicked off the race.
And you can see the two sides of that race laid out so clearly here. On the one hand, you've got the American-led Manhattan Project. Massive funding, huge industrial power, and a laser focus on just getting it done. And on the other, the German Uran Project. It was bogged down by war, sabotage, and, get this, a self-defeating ideology they called Aryan physics. They basically dismissed the work of Jewish scientists like Einstein as Jewish physics, which meant they crippled their own scientific foundation right from the start.
So, with the Germans pretty much stumbling over their own feet, the full immense power of the United States was aimed at one of the biggest and most secret projects in history, the Manhattan Project.
Just get a load of this number. 130,000. That's not a team, that's the population of a decent-sized city, and that's how many people worked on this thing. They lived in these secret cities, like Los Alamos, that were built from nothing in the middle of nowhere. And the wildest part? Almost none of them had any idea what they were actually building.
And then, it happened. July 16th, 1945, out in the New Mexico desert, the Trinity test brought the power of the atom to Earth for the very first time. The secret wasn't out to the world yet, but for its creators, everything had changed.
But a secret that powerful, a secret that can level cities, was never going to stay secret for long. The American monopoly on the bomb was about to end, and when it did, the entire game of world politics was going to be flipped on its head.
So get this, the Soviet Union was an ally during the war, but they were kept completely in the dark about the bomb. Well, they didn't stay there. Soviet spies, most famously a physicist named Klaus Fuchs, had worked their way deep inside the Manhattan Project. Fuchs didn't just pass along notes, he handed over the literal blueprints for the Fat Man bomb. And sure enough, by 1949, the Soviets tested their own bomb. The Cold War arms race was officially on.
After that, the dominoes just fell, one after another. The Soviet Union in 49, then the UK in 52, France in 60, China in 64. In just 15 years, the power to end the world went from being in one country's hands to many. And all of this led to one of the most terrifyingly logical ideas in history.
Mutually Assured Destruction. The acronym is MAD, and honestly, it was. The thinking was grim but simple. If you launch your nukes at us, we'll launch our nukes at you, and we'll both be completely annihilated. So nobody wins. That terrible balancing act is what kept the superpowers from direct war for decades.
Okay, so let's fast forward. What does all this mean for us, right now in 2026? The Cold War might be over, but the story of the atom, well, it's gotten a whole lot more complicated.
Now, at first glance, this looks like good news, right? The world's stockpile of nukes has dropped from a terrifying peak of around 70,000 warheads down to about 12,000 today. That's a huge reduction.
But, and this is a really big but, the number of bombs doesn't tell the whole story. Not even close. Today's weapons are a totally different animal. They are faster, smarter, and can be delivered by hypersonic missiles. We're talking weapons that move so fast they could make our current defense systems totally useless. It's a new, and maybe even scarier kind of arms race.
And that really brings us to the ultimate paradox of the atom. It's this perfect double-edged sword. On one side, you have this constant, existential threat, old weapons getting older, new hypersonic weapons getting faster. But on the other side, it could be a global solution. The same physics gives us things like MRIs and life-saving nuclear medicine. And maybe most crucially for us today, it offers a powerful source of carbon-free energy to help fight climate change.
So we end up right back where we started, with a question that pretty much defines our time. Splitting the atom was the ultimate test of our species' wisdom. Looking around the world today, with all its promises and all its perils, was that initial discovery back in a small Manchester lab our greatest achievement or our final mistake?